This video continues to focus on some of the available heat exchanger models on VapCyc. These models are available as both evaporator and condenser components. The heat exchanger models this video focuses on are the generic tube-in-tube heat exchanger, the generic plate heat exchanger, the ideal heat exchanger, the PHESim reader component, the constant load heat exchanger, the heat load-based heat exchanger, and the dummy component. The generic tube-in-tube heat exchanger is a simple UA-based zone-by-zone model. The model subdivides the total length into the number of phase regions for the heat transfer calculation. The edit window for the generic tube-in-tube heat exchanger includes 3 tabs: heat exchanger properties, heat transfer, and material properties. The flow configuration, refrigerant path, brine type, inner and outer heat transfer areas, tube length, refrigerant channel hydraulic diameter, brine mass flow rate, and inlet brine temperature are specified on the Heat Exchanger Properties tab. Water and refrigerant side heat transfer coefficients are specified on the Heat Transfer tab. Inner and outer material density, as well as costs, can be specified on the Materials Properties tab. The generic plate heat exchanger allows a user to enter in the number of plates, configuration of plates, number of segments, and number of plate heat exchangers in parallel. The first fluid is set as CO2, but there is a drop-down menu available to specify the second fluid. Underneath, plate geometry can be specified along with inlet conditions for the second fluid, and heat transfer coefficients and pressure drops for both fluids. There is the option to report power pump for the system for coefficient of performance calculations. Under the Tester tab, a user can enter input conditions for both fluids, and hitting Run will result in calculated output conditions for both fluids, as well as heat load. The ideal heat exchanger assumes no losses, and it requires that the user specify either the mean saturation temperature, dew point temperature, or pressure. Saturation temperature drop should be specified along with either the superheat or subcooling temperature as deemed necessary. The PHESim reader component is similar to the Coil Designer reader component in the sense that it can read in externally built components for use in a cycle in VapCyc. PHESim is used for plate heat exchangers. There are not any available sample PHESim components included in the VapCyc package, but the selection of a sample component would be similar to that of the Coil Designer reader component by clicking on Browse and finding the file that you want to upload. The constant load heat exchanger is a basic model that assumes a uniform constant heat load. A user can directly enter expected heat load and expected outlet saturation delta of the heat exchanger, with several options for the units in both entries. The heat load-based heat exchanger allows a user to enter saturation temperature drop and heat load. The heat load is assumed to be constant. Clicking on a text box results in a description of what the property is. In this case, the saturation temperature drop has to be in Kelvin and the heat load has to be in watts. The dummy component acts as a placeholder for a simple analysis of an abbreviated cycle. When this component is selected, no edit window shows up and no properties can be edited. For more information on the following compressor models, please refer to our first video on VapCyc heat exchangers on our Optimized Thermal Systems website. And for more information on these heat exchangers, please refer to our third video on VapCyc heat exchangers on our Optimized Thermal Systems website.